powers. Sometimes we come across very large or very small numbers. Writing these numbers in full form is a difficult process. Example, distance of Sun from the Earth is equal to 15 crore kilometer.
Mass of Uranus. It's 868 multiplied by 10 raised to the power 23 kg.
It is difficult to read, write and compare such large numbers. Calculations with such large numbers are very tedious. We face similar problems if we want to write the measure of the radius of the helium atom as 0.00000011 centimeter. In the following cases, we use exponents. Area of a square is equal to side into side, which is equal to side square. Volume of a cube is equal to side into side into side, which is equal to side cube. Thus, 5 cube is equal to 5 into 5 into 5, which is equal to 125. Here, 5 is the number that is multiplied by itself is called the base. 3, the number of times 5 is multiplied by itself is called the exponent, index or power. 6 exponent 20 base. We say 20 raised to power 6. Positive integral exponent of a rational number. Let a by b be any rational number and m be any integer. Then a by b whole raised to the power m is equal to a by b into a by b into a by b into so on until m times, which is equal to a into a into a and so on m times by b into b into b so on till m times is equal to a raised to power m by b raised to power m. Thus, a by b whole raised to the power m is equal to a raised to power m by b raised to power m, where m is a positive integer. Example, evaluate a 1 by 3 whole raised to the power 4, b minus 2 by 5 whole raised to the power 6. Solution, a 1 by 3 whole raised to the power 4, which is equal to 1 raised to power 4 by 3 raised to the power 4, which is equal to 1 into 1 into 1 into 1 by 3 into 3 into 3 into 3, which is equal to 1 by 81. B. Minus 2 by 5 whole raised to the power 6, which is equal to minus 2 raised to the power 6 by 5 raised to the power 6, which is equal to minus 2 into 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 minus 2 by 5 into 5 into 5, 5 into 5 into 5, which is equal to plus 64 by 15,625. 1 as the base and exponent. 1. The rational number 1 raised to any exponent m is 1. Example, 1 raised to power 9 is equal to 1 into 1 into 1, 1 into 1 into 1 into 1 into 1 into 1, which is equal to 1. 1 raised to power 3 is equal to 1 into 1 into 1, which is equal to 1. Similarly, 1 raised to power 20 is equal to 1. 2. Any rational number raised to the exponent 1 is the number itself.
Example, 3 by 4 raised to the power 1 is equal to 3 raised to the power 1 by 4 raised to the power 1 is equal to 3 by 4. Minus 5 by 6 raised to the power 1 is equal to minus 5 raised to the power 1 by 6 raised to the power 1 is equal to minus 5 by 6.
Remember, when exponent is not mentioned, this means that the exponent is 1. 3. The rational number minus 1 raised to any exponent gives 1 if the exponent is an even integer and minus 1 if the power is an odd integer. Thus, minus 1 raised to power 4 is equal to 1. 4 is an even positive integer and minus 1 raised to power 7 is equal to minus 1. 7 is an odd positive integer. Negative integral exponent of a rational number. Let a by b any rational number and n be a positive integer. Then a by b whole raised to power minus n is defined as a by b whole raised to power minus n is equal to b by a whole raised to power n. Let a by b be a rational number other than 0. Then a by b whole raised to power minus 1 denotes the reciprocal of a by b. Example, find the multiplicative inverse of 2 raised to power minus 4. Solution, multiplicative inverse of 2 raised to power minus 4 is equal to 2 raised to power minus 4 whole raised to power minus 1 is equal to 1 by 2 raised to power minus 4, which is equal to 2 raised to power 4. 0 as an exponent. If a by b be any rational number, then a by b whole raised to power 0 is equal to 1. Example, evaluate a minus 1 by 3 whole raised to power 0, b 2 by 3 whole raised to power 0. Solution, a minus 1 by 3 whole raised to power 0 is equal to 1, b 2 by 3 whole raised to power 0 is equal to 1. Laws of exponents. Let a by b be any rational number and m and n be any integers. Then a by b whole raised to power m multiplied by a by b whole raised to power n is equal to a by b whole raised to power m plus n. B a by b whole raised to power m divided by a by b whole raised to power n is equal to a by b whole raised to power m minus n. A by b whole raised to power m whole raised to power n is equal to a by b whole raised to power mn. D. A by b into c by d whole raised to power n is equal to a by b whole raised to power n multiplied by c by d whole raised to power n. E. A by b divided by c by d whole raised to power n is equal to a by b whole raised to power n divided by c by d whole raised to power n. F. A by b whole raised to power minus n is equal to b by a whole raised to power n, where n is a positive integer. G. A by b whole raised to power 0 is equal to 1. H. A by b whole raised to power 1 is equal to a by b. Example 1. Express the following in the exponential form. A. 64 by 125. B. minus 1 by 27. Solution. A. 64 by 125 is equal to 4 into 4 into 4 by 5 into 5 into 5, which is equal to 4 raised to power 3 by 5 raised to power 3, which is equal to 4 by 5 whole raised to power 3. B. Minus 1 by 27 is equal to minus 1 into minus 1 into minus 1 by 3 into 3 into 3, which is equal to minus 1 whole raised to power 3 by 3 raised to power 3, which is equal to minus 1 by 3 whole raised to power 3. Example 2. Find the value of A. 7 by 2 whole raised to power minus 2. B. Minus 4 whole raised to power minus 3. Solution. A. 7 by 2 whole raised to power minus 2 is equal to 2 by 7 whole raised to power 2, which is equal to 2 raised to power 2 by 7 raised to power 2, which is equal to 2 multiplied by 2 by 7 multiplied by 7, which is equal to 4 by 49. B. Minus 4 raised to power minus 3, which is equal to minus 1 by 4 raised to power 3, which is equal to 1 by minus 4 raised to power 3, which is equal to 1 by minus 4 into minus 4 into minus 4, which is equal to 1 by minus 64. Example 3. Evaluate. A. 3 by 4 whole raised to power 4 multiplied by 3 by 4 whole raised to power 6. B. 2 by 5 whole raised to power 4 divided by 2 by 5 whole raised to power 3. Solution. A. 3 by 4 whole raised to power 4 multiplied by 3 by 4 whole raised to power 6, which is equal to 3 by 4 whole raised to power 4 plus 6, which is equal to 3 by 4 whole raised to power 10. B. 2 by 5 whole raised to power 4 divided by 2 by 5 whole raised to power 3, which is equal to 2 by 5 whole raised to power 4 minus 3, which is equal to 2 by 5 whole raised to power 1, which is equal to 2 by 5. Example 4. Find the value of A. 3 raised to power minus 1 multiplied by 4 raised to power minus 1 whole raised to power minus 1 divided by 6 raised to power minus 1. B. 3 raised to power minus 1 plus 4 raised to power minus 1 plus 5 raised to power minus 1 whole raised to power 0. Solution. A. 3 raised to power minus 1 multiplied by 4 raised to power minus 1 whole raised to power minus 1 divided by 6 raised to power minus 1 is equal to 1 by 3 multiplied by 1 by 4 whole raised to power minus 1 divided by 1 by 6, which is equal to 1 by 12 whole raised to power minus 1 multiplied by 6 is equal to 12 multiplied by 6, which is equal to 72. B. 3 raised to power minus 1 plus 4 raised to power minus 1 plus 5 raised to power minus 1 whole raised to power 0 is equal to 1 by 3 plus 1 by 4 plus 1 by 5 whole raised to power 0, which is equal to 20 plus 15 plus 12 by 60 whole raised to power 0, which is equal to 47 by 60 whole raised to power 0, which is equal to 1. Example 5. By what number should minus 7 whole raised to power minus 1 be multiplied so that the product becomes minus 14 whole raised to power minus 1? Solution. Let us suppose that the required number be x. Minus 7 whole raised to power minus 1 into x is equal to minus 14 whole raised to power minus 1. Minus 1 by 7 into x is equal to minus 1 by 14. X is equal to minus 7 by 1 multiplied by minus 1 by 14, which is equal to 1 by 2. Hence, the required number is 1 by 2. Example 6. By what number should 1 by 2 whole raised to power minus 1 be divided so that the quotient is minus 5 by 4 whole raised to power minus 1? Solution. Let the required number be x. Then 1 by 2 whole raised to power minus 1 divided by x is equal to minus 5 by 4 whole raised to power minus 1. 2 divided by x is equal to minus 4 by 5 whole raised to power 1. Implies 2 by x is equal to minus 4 by 5. 2 is equal to minus 4 by 5 into x. X is equal to 2 divided by minus 4 by 5, which is equal to 2 multiplied by minus 5 by 4. This implies that x is equal to minus 5 by 2. Hence, the required number is minus 5 by 2.